Alright, so in this video, I'm going to be solving the problem 7 to the power of 100 minus 7 to the power of 97. So, for my solution, I'm going to rewrite my problem right here. And the first thing I'm going to do is I'm going to rewrite 100 as 97 plus 3. So I get 7 to the power of 97 plus 3 minus 7 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of 97 plus 3 is going to equal 7 to the power of 97 times 7 to the power of 3. And I have this minus 7 to the power of 97. Now from here, notice how both of my terms have 7 to the power of 97 in them. So I can simply factor out 7 to the power of 97, and I get 7 to the power of 97 times 7 to the power of 3 minus 1. And 7 to the power of 3 minus 1 is, well, 7 to the power of 3 is 343. So I get 343 minus 1, which is equal to 342. So I get 7 to the power of 97 times 342. So this is my answer in simplest form. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log 8 to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent, and for our equation, if x is 1, I get 8, if x is 2, I get 64, and if x is 3, I get 64 times 8, which is 512, and we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88, and I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11 So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer.